Welcome. In this web tutorial, I'll describe and briefly demonstrate two user-friendly, freely available web tools for targeting and evaluating forest conservation policy in Latin America. The video complements written instructions and metadata that are available for download in the dashboard of each tool. So those instructions provide a detailed version of the overview that I'm going to provide here. The web tools are accessible on a National Aeronautics and Space Administration server and can be accessed via the URLs in this slide. So the Forest Conservation Targeting Tool is available at fctt.sevierglobal.net, and the Forest Conservation Evaluation Tool is available at fcet.sevierglobal.net. The web tutorial has three parts. First, I'll briefly describe the project that generated this work, and then I'll describe and demonstrate the targeting tool, and finally, I'll describe and then demonstrate the evaluation tool. So first, an overview of the project. So the motivation for building these web tools is essentially that deforestation and forest degradation in Latin America are rampant. According to the UN Food and Agriculture Organization, deforestation in the region remains, quote, alarmingly high. So in the first decade of the 2000s, the average rate of deforestation in the region was 0.5% per year, which is about 5 times the global rate. That deforestation, along with forest degradation, has a number of serious environmental consequences. At the global level, it contributes to climate change and biodiversity loss. And at the local level, it contributes to soil erosion and the loss of hydrological services. Unfortunately, the resources, the human and financial and institutional resources that we have available to stem deforestation and forest degradation in Latin America are quite scarce. And therefore, it's really important that we maximize the bang for the buck from the resources that we do devote to addressing that problem. And that's the broad goal of these tools. It's to help improve the efficiency and the effectiveness of forest conservation policy in Latin America. So we've built two user-friendly web tools. One is for targeting forest conservation policies, that is identifying the places where these types of policies are going to generate the greatest conservation bang for the buck. And the second tool is for measuring the effectiveness of specific policies in stemming deforestation in specific places. So for example, how effective have protected areas in Costa Rica or payments for environmental services in Costa Rica been in stemming deforestation? The web tools are designed to be user-friendly and to have all of the requisite data on board. So building these tools has been a team effort, and before starting to describe them, I just want to make sure to give credit to the folks that were on this team. The main team consisted of 4 folks who at the time were at Resources for the Future, which is a nonprofit, nonpartisan environmental policy research institute in Washington, D.C. Those folks were myself, Alan Blackman, Jessica Chu, Alex Igorenkov, Len Goff, and Juha Sikamaki. In addition, that core team was supported by other researchers, both at Resources for the Future and at the University of Maryland Department of Geography, and they included Matt Hansen, Joe Mayer, Stephanie Najjar, Peter Potapov, and Yamil Tolera. I also want to take a second to acknowledge the funders of these tools. The principal funder was NASA's SEVERE program. And in addition, we received funding from SSYNC, the National Socio-Environmental Synthesis Center in Annapolis, Maryland, from the Gordon and Betty Moore Foundation, and from the Inter-American Development Bank. Okay, I'm going to describe now the Forest Conservation Evaluation Tool. I'll briefly describe the concepts and the data that underpin the tool, and then I'll demonstrate it. So this tool focuses on evaluating the effectiveness of already existing forest conservation policies in stemming deforestation. So while the targeting tool is focused on forest conservation policies that have not yet been implemented and is therefore forward-looking. You're thinking about where to cite policies in the future. This second tool is focused on evaluating already existing conservation policies, and it's backward-looking. The types of policies we're interested in are spatially delimited policies, policies that affect some places and not other places. So those type of policies might be, for example, protected areas or forest certification, payments for environmental services, community forestry. We're not able, using this approach, to evaluate the effects of policies that affect big swaths of territory, the entire countries or big regions, things like removal of subsidies on logging. We're interested in spatially delimited policies. The conventional approach to measuring the effectiveness of these types of policies in stemming deforestation is to simply compare the rate of deforestation inside areas affected by the policies with the rate of deforestation outside of these areas. The problem with that approach is that these types of policies are not randomly located. So many of these policies tend to be located disproportionately in places where rates of deforestation are relatively low. They're sparsely populated and minimal deforestation pressure. So, for example, protected areas tend to be located in remote places at high altitudes where there's not a whole lot of deforestation. So, therefore, if you use this conventional approach, comparing what's going on inside and outside policy areas, you tend to get biased results. You tend to find that these types of spatially delimited policies reduce deforestation rates. But that's often because you're just conflating the effects of the location of the policy with the effects of the policy itself. So to avoid that type of bias, over the past decade, a new, more rigorous approach has emerged. And in a nutshell, it entails comparing rates of deforestation in areas affected by a policy to rates of deforestation in control sites that are similar in terms of land characteristics that affect deforestation. And that can be done using matching or regression. So if you're not familiar with this approach, I've included at the bottom of this slide a citation to an introduction and a practical guide that was published back in 2013. But to make this method more intuitive, I thought I'd take a few minutes to give you an example or two of some recent work that applies this approach. So the first example is a study of the effectiveness in stemming deforestation of so-called paper parks. These are parks that are drawn on maps but have very little management or funding. One could imagine that parks like that in developing countries could stem deforestation, and that could happen if, for example, the drawing a park on paper creates an expectation that land use restrictions are going to be enforced sometime in the future. And therefore, folks that might engage in land use change, clear land to establish ranching operations might hesitate to do that inside protected areas because they understand that even if there's no monitoring and enforcement presently, there may be in the future. On the other hand, you could imagine that paper parks could exacerbate deforestation, and they could do that by essentially creating an open access regime where no one is really in charge of monitoring land uses. So the net effect of paper parks on deforestation is an empirical question. And in order to answer that question, we looked at the effectiveness of paper parks in stemming deforestation in Mexico during the 1990s. This was a period where there was very little funding or management of national parks. The average expenditure on protected areas during this period, during the 1990s, was on the order of about a penny per hectare per year. By comparison, here in the States during that period, we spent about $30 per hectare per year on national parks. So to measure deforestation, we used satellite data. We used a land use map from 1993, compared it with a land use map in 2000. And then to control for the characteristics of land, we used a variety of different GIS layers on geophysical, socioeconomic, and institutional land characteristics. And we used propensity score matching and covariate matching to control for land characteristics. There's a detailed discussion of the methods that we used and the results that we generated in a paper that was published in 2015 in Global Environmental Change. The citation is at the bottom of this slide. So here's just a picture of the parks that we were looking at. We were looking at the 56 national parks in Mexico that were created before 1993, the first year of our forest cover change data. And here is a couple of figures that that illustrate our results. So first, I'll show you the results that you would get if you use that naive approach that I described a minute ago of comparing deforestation rates inside and outside parks. So this is the graph on the left. The blue bar is the average rate of deforestation during this period outside of parks. So between 1993 and 2000, there was 16% deforestation outside of protected areas. The red bar is the average rate of deforestation inside protected areas during this period, which was 12%. The difference between those two rates, inside and outside of protected areas, is 4 percentage points. So if you were using this approach, you would conclude that protected areas reduced deforestation by 4 percentage points between 1993 and 2000. But as I mentioned a minute ago, those results are likely biased because they don't take into account, they don't control for the pre-existing characteristics of the land where protected areas were located. The figure on the right illustrates the result that you get if you do control for those pre-existing characteristics. The blue bar here on the right represents the average rate of deforestation on areas outside of parks that are similar to areas inside of parks in terms of characteristics that affect deforestation. So distance from cities, altitude, slope, and so forth. And as you can see, the average rate of deforestation on those types of sites was 12% during this period, which is the same rate as inside of protected areas. So using this method, we conclude that paper parks during the 1990s in Mexico, on average, didn't affect deforestation. There's a second paper that you might be interested in to get a sense of this approach. I'm not going to take the time to go through it, but the broad question we were asking in this paper is, what is the effect of indigenous management of forests in the Amazon basin in 4 countries, Bolivia, Brazil, Colombia, and Ecuador, on forest cover change between 2000 and 2012. I'm not going to take the time to go through it, but as I said, you can look at the paper if you're interested in what we found. Let me turn now to the features of the web tool, of the Forest Conservation Evaluation Tool. The geographic scope is the same as that for the Forest Conservation Targeting Tool. It's basically all of Latin America and the Dominican Republic, so Mexico, Central America, the Dominican Republic, and South America. The spatial unit of analysis that we use for this tool is a point. And we draw a point is simply a latitude and longitude coordinates that identify a location. And we include in the data that underpin this tool a sample of locations throughout Latin America. And we select these locations by overlaying a 1 kilometer rectangular grid on all of Latin America and the Dominican Republic. And so a grid where the grid lines are 1 kilometer apart vertically and horizontally. Everywhere with the grid lines cross, we select a sample point. So there are hundreds of millions of these sample points in our model. In order to analyze the effectiveness of a forest conservation policy, the web tool needs information on which points in that sample I just described are in a user-defined study area and are treated. That is, which of them are exposed to a forest conservation policy. And for the most part, our data on which points are treated is provided by the user. And users can identify treated points in three ways. First, they can use the tool to manually draw polygons that indicate which points are treated. Second, they can upload to the web tool shapefiles that do that. So for example, if a user has shapefiles of PES polygons, they can upload that to the tool, and the tool uses that information to identify the points that are treated. And finally, the tool has onboard data on protected areas. So if a user is interested in evaluating the effectiveness of protected areas in a given study area, they can use these onboard data on protected areas. As I mentioned a minute ago, a key element of the approach is that the forest conservation targeting tool uses is controlling for pre-existing characteristics of land where the forest conservation policies are located. And the tool has onboard spatial data on a variety of different land characteristics. Those characteristics include climatological characteristics. Specifically, the web tool has on board 12-year average temperature and precipitation. As for geophysical characteristics, it has on board all of the data that comes from a digital elevation map, including elevation, slope, and directional orientation. It has information on travel time from each point to the nearest population center, the Euclidean distance from each point to the nearest population center, the percentage of forest cover on each point in 2000. So each point corresponds to a 30-meter squared pixel in a forest loss map and a forest cover map. And so we know the percent forest cover in that pixel. It has onboard distance to the nearest cleared point in the year 2000. And it has socioeconomic characteristics. The population density in the area around that point, and data on the opportunity costs of retaining forest cover around that point. So this is a graphic that illustrates how these point level data are used in order to estimate the effectiveness of a forest conservation policy. But rather than lead you through this figure, I think I'm just going to demonstrate the tool because the tool incorporates the same workflow. So now I'm going to demonstrate the tool, which again can be found at fcet.severeglobal.net. Okay, now I'm going to demonstrate the forest conservation evaluation tool. Like the targeting tool, it has three main elements. The first one is a dashboard up here at the top. The second is a map interface. And the third is a toolbox that consists of, in this case, 10 tools. So the main way that users interact with the evaluation tool is through the tools in the toolbox. So that's what I'm going to spend most of my time in this tutorial talking about. But before I do that, let me just briefly mention, give you an overview of what's in the dashboard and talk a little bit about the map interface. So the dashboard has three pull-down menus. And the purpose is basically to provide users with metadata and background information and detailed instructions on the use of the tool. Most of these things are in downloadable PDF format. So for example, in the how-to menu, if you click on description, you get a PDF that provides an overview of the evaluation tool. The most important option in these pull-down menus is instructions. If you click on that, you get a PDF with detailed instructions on how to use the evaluation tool. So hopefully any questions that aren't answered in listening to this web tutorial, will be answered in these written instructions. There's also frequently asked questions, a link to this video tutorial, and a format for submitting questions. There's also an email address where you can submit your questions, and we've provided that email address at the bottom of each of these pull-down menus. The About pull-down menu can lead you to metadata, to a document that acknowledges our sponsors, one that acknowledges the folks that help build this tool, and that same email address. The feedback menu provides links to a forum where you can post questions and comments. So the map interface should be familiar to anybody that's used Google Maps or similar programs. You can click and drag to get to where you want to go. You can also use this pan tool and this zoom tool. These are similar to the tools I showed you in the targeting tool. If at any time you get lost, you can always click on this reset all button in the lower left-hand corner that brings you back to the start, to the place where you start when you use this URL. Okay, so let's now talk about the tools in the toolbox. So unlike the targeting tool, the tools in this toolbox are structured. So you have to click through them in order from 1 to 10. So in order to provide guidance on how to do that, what each tool does, and how to use it, we've provided a series of pop-up boxes that you can access, one for each tool and one that provides an overview. So I'm just going to read, these are for the most part quite brief, so I'm going to just read them as we go through the toolbox. So I'll start with the overview menu. As we know, the FCET measures the effect on deforestation of spatially delimited forest conservation policies, controlling for the characteristics of the land where the policies are located. To use this tool, you have to open, as I said a second ago, each of the 10 tools in order starting from 1 and finishing at 10. There are green colored buttons for each tool that you have to click on to submit your modeling choices to the evaluation tool. For each tool, you can launch an information pop-up box like this one that provides brief guidance. For more detailed guidance, please consult the detailed instructions that can be downloaded from the dashboard. Okay, so let's go to the first tool in the toolbox, which is Define Study Area. So I'll click on the question mark icon that brings up the pop-up box. It says this tool allows you to define a study area, an area comprised of first-level administrative units, where you wish to evaluate the effect of the forest conservation policy. When you open this tool, the map's going to display administrative units with blue outlines. To include an administrative unit in your study area, single click on it. It's important that you only click once, because if you click twice, it's going to select that unit and deselect it. Anyway, after you click once, the unit's going to be displayed in beige, and the forested points inside it are going to be displayed in green. For computational efficiency, only a random sample of the underlying sample points are going to be displayed in green when the map is zoomed out. That's because there are hundreds of thousands in any, most study areas are going to have hundreds of thousands of these sample points, and it's just not computationally feasible to display them all if you're zoomed out and you can see all those hundreds of thousands of sample points. So you only see a random sample of them, but if you zoom in, you can see all of the points in your study area. As I said, if you click once on the administrative unit, it selects it. If you click twice, it deselects it. When you're finished defining the study area, just click the green button, which says Submit Selection. And then when you do that, the administrative boundaries are going to disappear. Those blue boundaries are going to disappear, but the green points selected inside will continue to be displayed. So let's see how that works. We open the tool. The tool displays first-level administrative units in blue. For this demonstration, we're going to be looking at, we're going to be using as a study area the western part of Panama for no good reason. So here's Panama. And the darker boundaries are the boundaries of the country. Oops, sorry, that's Costa Rica. Here's Panama. The darker boundaries are the boundaries of the country. And we're going to pick the second level administrative units in the western part of the country. So if I click once on this administrative unit, it's going to turn beige. And then as I mentioned, it's going to display a random sample of the underlying forested points. There's another administrative unit. There's a third, fourth, a fifth, and a sixth. So we'll make this our study area. If I'm satisfied with the study area, I just hit submit selection. And the blue boundaries disappear, but the green boundaries continue to be displayed. Also, the tool is going to display a red check mark that indicates that we've successfully completed this step and can move to the next one. The next step is to define the outcome period. So the tool allows you to select outcome years, the range of years between 2000 and 2012 over which the effect of the conservation policy on deforestation is measured. So for example, if you want to measure the effect of a policy on deforestation from 2004 to 2008, there's a slider, which I'll show you in a minute, where you can set the sliders to 2004 and 2008. Okay, so let's do that. We're not going to, let's say we want an outcome period of 2005 to 2012. So I'll just move the left-hand slider to 2005. I'll keep the right-hand slider at 2012, and I'll hit submit selection. I get a red check mark that indicates that I've successfully completed this step, and I can close that tool and move to the next one. So the next one is limit point types. I click on the question mark icon, and the pop-up box says this tool allows you to exclude from the sample of points those which have less than a minimum percentage forest cover and or those that have more than a maximum amount. So for example, if you want to exclude points with less than 40% forest cover and more than 90% forest cover, you would move the sliders to 40 and 90. Okay, so here's the slider. If I move this, I'm going to move this to 25% forest cover. That means that when I hit submit selection, it's going to drop from the sample of points those that have less than 25% forest cover. And we're using a map of forest cover from 2000 from the Matt Hansen et al., University of Maryland, forest loss data. So I'm going to hit submit selection, and you can see I have a smaller set of points now, and that's because I've dropped points that have less than 25% forest cover. I get a red check mark, and I can move to the next box. The next box is select treatment points, the next tool. This tool allows you to select treatment points, those points in the study area that have been subjected to the forest conservation policy. You can do that in three ways. You can upload a shapefile that defines the spatial extent of the policy. You can use the manual selection tool, and you can use the onboard data on the location of protected areas. So let me briefly show you each of those. Let's say I was interested in, there were PES polygons. There was a PES program in Panama, and I had the polygons of the areas where payments had been made. And I wanted to tell the Forest Conservation Evaluation tool which points were inside those polygons. I could upload shapefiles for those polygons. So I click on option 1, upload a shapefile, upload treatment polygons, and in the usual way, I can browse and upload an SHP file, SHX file, DBF file, and a PRJ file. I'm not going to do that though. A second way to identify the treated points, those subject to the policy, is to manually delimit them. So let's say there were 3 areas where I knew land managers have been given technical extension in forest management, and I wanted to see if that had any effect on deforestation. And I wanted to draw those polygons by hand. I could use this toggle polygon selection tool. So you can see, by the way, as I zoom in, the tool automatically displays more of the underlying points. If I zoom all the way in, I get the complete set of points. The tool displays the complete set of points. In any case, let me zoom back out and show you this polygon selection tool. So if I click on polygon selection tool, now the pointer, I get a pointer with a circle. And when I single click, I can define the vertex of a polygon. And I can define a polygon with as many vertices as I want. It is the last polygon the last vertex that I click on, I have to double click, and that'll define a polygon. So let's say that's the first polygon. I double click. I can define a second one and a third one. I can define as many as I want, but let's say I was interested in those three. I could submit the selection. And now the treated points, the ones that have been subjected to the policy, turn from green to red. I'm not going to do that, though. I'm not going to use those points. So I'm going to hit clear treatment points, and those red points go away. The option that I'm going to use to identify treated points is to use the onboard data on the location of actual protected areas. So these data come from the World Database on Protected Areas. First thing that I need to do is tell the tool where my study area is. So I'm interested in protected areas in Central America. I hit Submit Selection, and then the tool identifies those points inside actual protected areas in this study area that I've defined. So I get my red check mark, and I can move on to the next tool in the toolbox, which is Select Control Points. So this tool allows you to select control points, points in the study area that have not been subjected to the forest conservation policy and that are likely to include at least some points similar to those that have been subjected to it. Control points are those from among which matched control points will be selected in step 6. You may want to limit control points to the points you believe have unobserved characteristics that affect deforestation. That is, characteristics not captured by observable characteristics, the covariates included in step 6. You can select control points in 4 ways: by selecting the entire study area, uploading a shapefile, using the manual selection tool, or using proximity to policy areas subtool. Okay. So again, I'm telling the web tool which points I want to use as control points, or which points can be among those from which I select matched control points. And I want to limit this to points that have at least the possibility of being similar to the red points. So I can do that by uploading a shapefile. I can do that by using manual selection. But what I'm going to do is to just select the entire study area. So I'm telling the tool that you can choose match control points from anywhere outside those red areas. When I do that, that set of potential match control points turns from green to blue. And I get a red check mark, which means that I can move to the next tool in the toolbox. Okay, the next tool is Select Matched Control Points. This tool allows you to select matched control points, which are control points that are similar to treatment points. The evaluation tool estimates the effect of the forest conservation policy on deforestation by comparing the average deforestation rates on treatment points and on these matched control points. To select matched control points, you have to complete 2 steps. First, you have to select the covariates from a list of 13 land characteristics. And you want these to be covariates that are going to be used to define similarity. And after you've done that, you have to click on the Run Statistical Matching button, which is going to cause the evaluation tool to display the match control points in yellow. Okay, so, first thing we have to do is select covariates. there's a yellow warning sign here because I inadvertently closed this before I completed it. But I think if I go ahead and select these covariates, it's going to do what we need it to do. So here are the 13 covariates, these point characteristics that could be used to define similarity. For the sake of convenience, I'm going to just choose the first four. And to choose them, I select the ones that I want to choose, and I can select them one at a time. And then I can click on this Add to Selected, this button that moves these covariates from the left-hand panel to the right-hand panel. Alternatively, I can control click and to select multiple covariates and move them all at once. Okay, so those are the four that I'm going to use: forest cover, the percent forest cover in 2000, the elevation, the directional orientation, and the slope. I hit Submit Selection. And then the last step is to run statistical matching. So the matched control points are displayed now in yellow. So these matched control points that are points that are similar to the points in red, the treated points, in terms of those covariates that I just identified. So slope, aspect, percent forest cover, and elevation. As you can see, there are fewer yellow points than there are red points, and that's because we're using matching with replacement. So some points can be used as a match more than once. Okay, now I can move on to the next tool, which is Check Balance Statistics. So this tool allows us to generate balance statistics in either tabular or graphical format that indicate how similar the matched control points in yellow are to the treatment points in red. The tool includes three subtools. One is Plot Balance Statistics, which generates a graphical representation of similarity with respect to each covariate that we selected in the previous step. Tabulate Balance Statistics by covariate, which generates the same information in tabular format. And View Summary Balance Statistics, which generates statistics that represent similarity across all covariates selected in step 6. Median standardized bias below 3 to 5% is typically viewed as acceptable. Okay, so let's open this tool, and we're going to click on each of these three submenus in sequence. Okay, so this graph shows balance statistics. It shows how similar the yellow points are to the red points in a graphical format. So on the vertical axis, we have percent bias, which is just the variance adjusted difference in means for each covariate before matching, which is the bar in blue, and after matching, which is the bar in yellow. So as you can see, the bar in yellow is significantly smaller than the bar in blue for 3 of these covariates, meaning that after matching, the percent bias is much lower. For the 4th covariate, however, for slope, it's significantly higher after matching, and that's not uncommon in propensity score matching analyses. You have multiple characteristics that you're matching over. You improve the bias for most of them, but in some cases exacerbate the bias for others. So that's that information in graphical format. We can also view the same information in tabular format. And finally, we can view summary balance statistics. So these are just statistics that tell us not for each covariate, but overall how good the balance is. An often used measure is the mean or median bias across all of the covariates. The next tool is the tool that presents the results from our matching analysis. This tool allows you to view the results of the analysis of the forest conservation policy's effect on deforestation in tabular and graphical format. Okay, so we click on View Results. And the first set of results are similar to the results that I showed you in the overview of the Forest Conservation Evaluation Tool when I was describing our analysis of the effect of paper parks in Mexico on deforestation. So this first blue bar tells us the average rate of deforestation during the outcome period that we defined for all of the untreated points, all of the blue points. What we're seeing is that the average rate of deforestation during this period was 3.7%. The red bar tells us the average rate of deforestation on points inside protected areas. It was 0.6%. And the yellow bar tells us the average rate of deforestation on matched control points, on the yellow points. So as you can see, the average rate of deforestation on the yellow points is significantly smaller than the average rate of deforestation on all of the blue points. So our estimate of the effect of protected areas on deforestation during this period is the difference between this red bar and this yellow bar, the average rate of deforestation on the red points and on the matched control points, the yellow points. And that difference is 1.7 percentage points. So that's our estimate of the effect of protected areas on deforestation in our study area. And below the graphical results are the results in tabular format. The next tool allows us to check the sensitivity of our results to unobserved confounders. So one of the limitations of the method that we're using, propensity score matching, is that we're not controlling for confounding factors that we can't observe. And this sensitivity check allows us to see how sensitive our results are to that to that limitation. So this tool gives you a sense of how robust and reliable the results are from the previous step. More specifically, it checks the sensitivity to unobserved heterogeneity of the evaluation tool's estimate of the effect of forest conservation policy on deforestation. I'm not going to take the time to describe how this works in detail, but if you are interested, you can read more about this in the metadata, which is available for download in the dashboard of the tool. So this sensitivity analysis is called Rosenbaum bounds, and this box displays the data that you need in order to conduct the sensitivity check. Okay, so those are the first 9 steps. The only one that remains is to download a report that summarizes all of the choices that we've made and all of the results that we've generated. This tool outputs a report in PDF format that contains all the choices we've made, the bound statistics, results, and sensitivity analysis generated in the last several steps. So I'll just hit download complete report. And we get a PDF that indicates the date of the study area, the outcome period, how we limited our plot types, how we selected our treated points, how we selected our control points, how we selected our matched control points, what covariates we use, what the matching estimated ones. Here is a figure, the map that shows the treated points, the matched control points, and the other control points. And here are our balance statistics in graphical and tabular format. And here are results in graphical and tabular format. So again, that's it. I hope this was useful. And If you have questions that weren't addressed in this brief overview, please consult the detailed instructions that can be downloaded from the dashboard. Thank you.